A full year of food: tomatoes, peppers, beans, squash, lettuce, cucumbers, herbs, greens, a complete, producing, nourishing garden that ran from the first thaw to the last frost, and fed a household through every week of every season. And the total amount spent on seeds for that entire year, zero. Not a reduced amount, not a discounted order from a cheaper catalogue, $0. Because every seed that went into the ground that year came from the harvest of the year before. Saved, dried, stored, and replanted with knowledge so simple and so old that every farming family in the world practiced it as a matter of basic survival for 10,000 years, right up until the moment the seed industry figured out how to make it unnecessary, and then quietly made sure most people forgot it was ever possible. This is seed saving. Not the complicated, lab-grade, obsessive version that specialty seed libraries make it seem like. The ordinary, practical, do-it-in-your-kitchen version that requires no equipment beyond an envelope, a pen, a warm, dry surface, and the understanding of a few biological principles that take about 20 minutes to learn and last a lifetime. Every tomato you've ever eaten contains seeds capable of producing the same tomato next year. Every pepper, every bean, every cucumber, every squash. The seed is already there, it's already in your food. The only question is whether you let it dry and keep it, or whether you throw it away and pay someone to sell it back to you in a paper packet next spring. That choice, made by millions of people every harvest season without ever fully understanding what they're choosing, is worth billions of dollars annually to an industry built on the assumption that you will always throw it away. The practice of seed saving is as old as agriculture itself, and was, until approximately 70 years ago, simply what farming meant. Every agricultural civilization in history, without exception, maintained its own seed supply. The ancient Egyptians stored seeds in sealed ceramic vessels with such care that viable wheat grains have been recovered from tombs sealed for 3,000 years. The Inca civilization maintained dedicated seed storage facilities, colcas, at precise altitudes across the Andes, engineered to maintain the temperature and humidity conditions for long-term seed viability, storing hundreds of varieties of potato, maize, and quinoa as biological insurance against crop failure. Indigenous agricultural communities across North America maintained seed lineages of corn, beans, and squash, the three sisters, that had been selected, saved, and improved by continuous human cultivation for thousands of years before European contact, producing varieties specifically adapted to the microclimates of individual valleys and hillsides. The Svalbard Global Seed Vault, built into a Norwegian mountain above the Arctic Circle, and maintained by governments and international organizations as a backup for global agricultural biodiversity, contains over 1 million seed samples representing the saved heritage of 10,000 years of human plant cultivation. The scientific community understands with complete clarity that seed saving is not a hobby. It is the foundation of food security. The FAO has stated formally that the erosion of seed diversity through the consolidation of commercial seed supply represents one of the most serious long-term threats to global food systems. This is not a fringe position. It is the official position of the United Nations Food Agency. And yet the average gardener in the developed world buys new seeds every spring from a catalogue, throws away the seeds from their harvest every fall, and has never been taught the connection between those two actions. Here is why that connection was deliberately severed. The commercial seed industry, which consolidated dramatically in the latter half of the 20th century into a small number of multinational corporations, has two products that require seed saving to be abandoned for their business model to function. The first is the F1 hybrid. An F1 hybrid seed is produced by crossing two distinct parent lines to produce offspring with specific, desirable traits: high yield, uniform appearance, disease resistance. F1 hybrids perform excellently in the first generation. But the seeds saved from F1 hybrid plants do not reliably reproduce the parent. They revert toward the original parent lines, producing plants of unpredictable and generally inferior characteristics. A gardener who saves seeds from an F1 hybrid tomato and plants them the following year will get tomatoes, but not the same tomatoes. This characteristic is not an accident. It is the design. It ensures that anyone who wants the same results next year must purchase new seeds rather than saving last year's. The second product is the patented variety. a plant variety developed through breeding or genetic modification, and legally protected such that saving and replanting its seeds constitutes intellectual property infringement. Monsanto, now part of Bayer, employed investigators to identify farmers who saved and replanted patented seed varieties and pursued legal action against them, cases that reached national news coverage and the Supreme Court of the United States. The message delivered to farmers was clear. Saving seeds is legally risky, technically unreliable, and commercially unnecessary. The message was effective. Within 2 generations, the practical knowledge of seed saving, which every farming family possessed as basic literacy for 10,000 years, became a specialty skill practiced by a small number of dedicated enthusiasts, while the majority of gardeners and small farmers paid annually for seeds they could have produced themselves. They didn't take this knowledge away. They made it seem obsolete. And then they charged you for the replacement. You've already saved seeds without realizing it. Think about the last time you cleaned out a pumpkin to carve it for Halloween, or scooped the seeds from a butternut squash before roasting it, or ran your finger along the inside of a pepper to remove the seeds before cooking. You held viable planting material in your hand, seeds fully capable of producing next year's crop, and you rinsed them down the sink. Or think about the tomato seeds clinging to the cutting board after slicing tomatoes for a salad. Tiny, pale, surrounded by the gel coating that every gardener who has ever tried to dry tomato seeds without preparation knows will cause them to clump and rot before they dry. You've seen these seeds your entire cooking life. You just never connected them to the packet on the garden center shelf because the gap between those 2 things, between kitchen waste and next season's garden, was never shown to you as bridgeable. It is. It always was. And crossing it takes about 10 minutes of knowledge. Here is how seeds work, simply stated. A seed is a dormant embryonic plant, protected by a seed coat and supplied with a small reserve of stored nutrition to fuel germination before the seedling can photosynthesize independently. Seeds remain viable, capable of germinating, for periods ranging from 1 year for onions and parsnips to 5 or more years for tomatoes and squash, to decades for some species under ideal storage conditions. The enemies of seed viability are moisture, heat, light, and oxygen, all of which accelerate the metabolic processes that exhaust the seed's stored energy and degrade the embryo's cellular integrity. Protecting seeds from these enemies is the entire technical challenge of seed saving. The solution is dry, cool, dark, and sealed, conditions achievable in any home with an envelope, a glass jar, and a kitchen cupboard. The biology of seed saving requires additionally that you save from open-pollinated or heirloom varieties, not F1 hybrids, because open-pollinated plants reproduce true to type from saved seed. An open-pollinated brandywine tomato produces seeds that grow into brandywine tomatoes. This is the fundamental selection criterion. Open-pollinated varieties are the seed-saving gardener's material. The packets are labeled, the seed catalogs specify, and once you have an open-pollinated variety in your garden, you never need to buy that variety again. Here is how you do it, crop by crop, starting with the easiest. Beans and peas are the entry point for every beginning seed saver because they are self-pollinating. The flower pollinates itself before opening, meaning cross-pollination from other varieties is essentially impossible, and the saved seed is genetically identical to the parent plant. Simply leave a selection of your best-performing bean or pea plants unharvested at the end of the season. Allow the pods to dry completely on the plant until they are brown, papery, and the beans inside rattle when shaken. Pull the entire plant, hang it upside down in a warm, dry space for 2 more weeks to ensure complete drying. Then shell the beans into a paper envelope or glass jar, label with variety and year, and store in a cool, dark, dry place. Done. Your entire bean and pea seed supply for next season costs nothing and takes 10 minutes of actual work. Tomatoes require one additional step, a fermentation process that removes the gel coating surrounding each seed, which contains germination inhibitors and harbors seed-borne pathogens. Scoop the seed gel from fully ripe, best-performing tomatoes into a small glass with an equal volume of water. Leave it at room temperature for 2 to 3 days, stirring daily. A mold layer forms on the surface. This is normal and part of the process. The viable seeds sink to the bottom, while the gel and non-viable seeds float. Pour off the floating material and mold, rinse the sunken seeds thoroughly in a fine strainer under running water, spread them on a non-stick surface, a ceramic plate, a piece of glass, and allow them to dry completely for 1 to 2 weeks in a warm, airy location out of direct sunlight. When seeds snap, rather than bend when folded, they are dry enough to store. Peppers are simpler. Cut fully ripe peppers, scrape the seeds onto a plate, and dry it